MS Ramaya University of Applied Sciences.
Charging and discharging of a capacitor. Hello students, let us discuss determination of the capacitance of the capacitor and the dielectric constant of the material of the capacitor. Let me discuss the working principle of the capacitor. A capacitor is a passive electric device that stores electric energy. Stored electric energy is given by the formula E is equal to half CV square, where V is the voltage across the capacitor and C is the capacitance of the capacitor. In parallel plate capacitor, two conductive surfaces are separated by an insulation layer. By knowing the area of the surface, separation distance, dielectric constant of the insulator, its capacitance can be calculated. During charging, the voltage across the capacitor increases and reaches a saturation value. The rate of increase of the voltage depends upon the resistance and the capacitance of the circuit. During discharging, the voltage falls down exponentially. The rate of decrease in voltage is also a function of resistance and the capacitance of the circuit. By plotting the voltage versus time for charging and discharging on a sample graph, find the point of intersection in the time axis given by Tp. By knowing the value of resistance and Tp, one can calculate the capacitance of the capacitor if resistance is known. Once capacitance is known, the relative permittivity of the insulating material can also be calculated. Note that while discharging, care should be taken to see that the discharging starts when the voltage across the capacitor is saturated.
Hello students, in this experiment we are going to measure capacitance of a capacitor and dielectric constant. For studying dielectric constant and capacitance of a capacitor, we need CR circuit board, digital stop clock and connecting wires. Now CR circuit board consists of one switch for on and off, 3 resistors, 3 capacitors, voltmeter, milliammeter and a variable power supply. Along with that, we have one charging and discharging switch and dump switch. Now we will do the circuit connections. Positive of voltmeter will be connected to input positive. Negative of voltmeter will be connected to negative of the input. Voltmeter positive will be connected to voltmeter positive. Negative of voltmeter will be connected to negative of voltmeter here. Positive of milliammeter is connected to positive of milliammeter. Negative from milliammeter is connected to negative of milliammeter. Then resistor and capacitance we need to connect. Resistance one end will be connected to here. Capacitance one of the capacitor C1 I am connecting to the other end. So R1 and C1 are connected in the circuit. Now let us perform the experiment. Switch on the apparatus, switch on the CR circuit board power supply, and before performing the experiment we need to turn the input voltage knob to maximum. Then simultaneously switch on the charging and stopwatch. Now note down the reading for every 10 seconds. voltage and corresponding time. Note down the voltmeter reading for every 10 seconds until the voltmeter reading shows constant value. Now, after that, switch off the timer, and then now we have to take discharging voltage readings. For that, turn the switch to discharging mode and stop clock simultaneously. Note down every 10-second voltmeter readings until the voltmeter reading shows 0 voltage. Repeat the procedure for R2C2 and R3C3 combinations. From obtained values of voltage and time, plot the graph by taking voltage along y-axis and time along x-axis. From the graph, obtain time constant for given combination of capacitor and resistor. From obtained value of time constant, we can calculate capacitance of a capacitor and dielectric constant.
At MSR UAS, we spark your imagination unlike any other.